Hi everyone, my name is Ishan Desai. I am a upcoming healthcare architect in HOSMAC, and today I am joined with Shantanu sir, who is a
Hi.
resident biomedical engineer at HOSMAC. And this is an interview to understand what the importance of a biomedical engineer is and why a client should hire them. First, a brief introduction about sir. So, Shantanu Thatte has 20 plus years of experience in the healthcare industry with prime focus in biomedical engineering in predominantly the hospital domain. Shantanu has a BE in biomedical engineering and a postgrad degree in hospital management. He has worked with established hospitals like Bhatia Hospital, Hiranandani, Patni Hospital, Vedanta with incremental roles. Shantanu has rich experience in medical equipment planning and procurement with a core specialty in the making of techno-commercial reports. He has authored The Careers in Biomedical Engineering, an academic book approved by Mumbai University as a reference guideline for the final year BE students as a part of their curriculum. We're very excited to have you for this podcast.
Thank you, Ishan. Thank you for kind of good introduction. At the outset, thank you for giving this opportunity. I'm very excited about this particular kind of podcast because I think this is the first ever podcast for a biomedical engineer with HOSMAC within HOSMAC, and I think the target audience takes away a good message out of our conversation. So
Exactly.
thank you.
Thank you. It's a lot to learn also for someone who is not from a healthcare background and
Yes, I
wants to
think so.
understand how hospitals and healthcare works in general.
Right.
Okay. Why a client should hire a biomedical consultant? The first question is let's learn what biomedical engineer is, what the work profile of it entails.
Okay, see, biomedical engineering profile is typically like any other engineering profile, say a computer engineering or a civil or some mechanical. So it's a 4 years degree, professional degree course. Okay, if I'm not wrong, it started way back in late 80s, 1986 or 87 was the first batch to start with. And at that time, there were 3 colleges running this particular course. In the mid time, it had rose up to 7 colleges. Ironically, the current status is there are hardly 2 colleges left who are the biomedical basically running this particular course. I mean, this is the can't help it for better, but this is the current scenario. So, if I have to define biomedical engineering, uh, biomedical engineering offers a comprehensive range of the technical and clinical services to the ongoing support of the medical equipment. How do I classify further? Suppose a manufacturer, a biomedical scientist, the one who makes an equipment is a biomedical engineer.
Okay.
See, take a small example of glucometer or say a stethoscope. Making this equipment, making this medical instrument, devices, medical furniture, the one who manufactures is a kind of biomedical scientist. Okay, see, making this CT scan, X-ray takes a lot of effort. It's a Herculean task.
Yes.
It's not that easy job. Too many minds, too many hands work together. The biomedical scientist has to apply his technical skills. Making an MRI is one of the toughest job on earth. But the one who makes this, the manufacturers, the medical equipment, is a biomedical scientist. Okay, it's not you understand. It's not an easy job.
Yes.
So the manufacturer. Then, if I have to tell you, the one who sells this equipment to the customer. See, selling an equipment to the customer, unless the customer requires it, it's again a tough job. See, if I come to you tomorrow selling a policy, any policy, you will keep me away from you for some time unless you require it. Similar ways, a biomedical engineer sells the equipment to the customer from hospital to hospital. So vendor, basically, the manufacturer makes the equipment, the vendor sells the equipment. The person who sells the equipment with the background of technical knowledge is a biomedical engineer. Okay. Third is service engineer. See, all these equipments are costly equipment. Nothing is kind of at dirt cheap price. Take an example of ECG machine. ECG machine may cost you around say 2 lakhs. So if the machines are kind of prone to fail, you cannot replace this machine or cannot buy these machines off the counter or off the shelf over the counter. So you require a service personnel who can repair, who can service, who can overhaul, who can maintain this equipment. So service engineering, who has the who has the biomedical backdrop, is a biomedical engineer. So you start from the first is manufacturing, second is sale, third is service. Who is the fourth one? Now, if you see, AI is come into every scenario, every kind of discipline there is AI. So there is similar way AI is come into the biomedical engineering. In what way? See, MRI. Now, MRI scan cannot start unless the RF door, the outside door, closes.
Yeah.
Okay, so this is the AI feature recently added in the equipment.
Okay.
How does it help? It helps preventing the occupational hazard.
Hmm.
Okay, so nothing will be pulled inside if the door is open and if the magnet is on. So that is the AI feature, a safety feature, which is helping out the working technicians, doctors, everyone, the healthcare professional.
Correct.
Similar ways, a ventilator which got very famous in the COVID time. Ventilator, if it is on the patient and the patient say those O2 saturation starts dropping below 94, it automatically enhances without the intervention of the doctor the upper level unit. It goes up the level of what the O2 level or the O2 level set for the ventilator, it goes on automatically. So that is again an AI feature. So
Correct.
who does it? Now, there are rapid advancements in the medical technology. So
Hmm.
who is doing this day in day out is the R&D person, the
Hmm.
R&D engineer. So the
Correct.
R&D engineer is also a biomedical engineer. So manufacturing, sales, service, R&D.
Hmm.
Fifth is, see, you have a medical equipment costing in the range of lakhs, crores. The high ticket, high modality equipment, as you buy, it goes up the ladder. So can you just keep the equipment parked in some kind of corner without using it? It's a
No.
wastage of everything, the technology, the money. So the one who teaches or trains you on how to use the equipment effectively, what are the do's and don'ts, is the person, is the application engineer. He is also a biomedical engineer. Okay.
Okay.
Not only that, a clinical specialist, suppose you are a new doctor or someone is a new technician or a nurse, someone has to kind of make them understand how to interpret the reports, how to read the ECG report, how to interpret the CT or MR report. The who teaches them? I mean, apart from the curriculum, what you normally take, what normally takes in the colleges and institution, is a clinical specialist who teaches the end user on how to effectively use the equipment.
Correct.
So even this clinical specialist is a biomedical engineer. And last but not the least, where I worked for the maximum time of my career, is a resident biomedical engineer working in the hospital 24/7, 365, whatever you call it.
Okay.
Okay. Now, what does it entail for a resident biomedical engineer? It's a code blue function. Okay. A biomedical engineer in a hospital is accountable and responsible for the overall functioning of the entire medical equipment, right from its acquisition till its retirement. So what does it entail further? Attending breakdown calls, doing all sorts of maintenance of the equipment, servicing, overhauling, liaising with the vendor. All the time you should see that the equipment is up and running. Because why? Because biomedical engineering performance is directly proportional to the patient safety and treatment, and indirectly proportional to the hospital's cash flow management. So this is very, very critical, and it's a code. Why I say code blue? Because imagine a situation, Ishan. You are in operation theater. Your beating heart surgery (CABG) is going on, and the heart lung machine is the kind of paramount importance in that particular scene. If that doesn't function,
Mhm.
you understand kind of the gravity of the situation over there. Or suppose you are in ICU and ventilator doesn't work. What type of the tension that gets built? So the biomedical engineer applies his brain, his technical skills, provides a better alternative at that particular time spontaneously. So he is also of great importance. So
Correct.
all these engineering profiles put together is biomedical engineering.
Okay. Understood. So the biomedical engineer has a base of medical or engineering. How does it
It's an
work?
engineering course, as I
Okay.
told you. It's a 4 years professional degree course,
Okay.
but you get to understand the anatomy, the physics or physiology,
Okay.
while the course is on.
Yes.
Yeah, so you have biology, you have technology, you have science, all mixed up together.
Wow.
Yeah,
Great.
is I mean, is as I said, it came into late 80s,
Hmm.
but still, unfortunately, it's still under the developing stage.
Yes. Mhm.
That's the scene.
Okay.
Okay.
Wow, it was great learning about this profession, something that is very new and modern.
Yeah.
Okay. So the next question I would ask is, when and why would one require the consultancy of biomedical equipment?
Okay. See, Ishan, there are different types of hospital.
Hmm.
Leave aside it's a government or it's a private organization. Let's keep that aside. Otherwise, there are different types of hospital. What do I mean by that? Say a primary care hospital or a secondary care hospital. Primary is like a chain, poly chain. Clinics poly chain. okay, where a patient meets a doctor for a basic ailment. Secondary is typically like a boutique hospital with 2 or 3 core specialties, suppose ophthal, ENT, or a dental, or a gynec. The hospital will be kind of 50 beds capacity and will kind of cater to only 2 to 3 core specialties.
Okay.
But once you enter to the higher level, up the ladder and go into the multidisciplinary or multi-speciality, quaternary care, tertiary care types of hospital, in this kind of zone, for every organ of the body, you will have a kind of, every speciality. Okay, I mean, you have then cardiac, you have neuro, you have ortho, you have ENT, opthal, you name the organ, you will have a specialty. So in this, in tertiary care and quaternary. Quaternary is where the transplants take place. Your renal transplant, your liver transplant, all those, take place in the quaternary care. So once you are in this creme de la creme zone, uh, the clinical spectrum also widens. As I said, it ranges from cardiac to a basic, kind of gynec or general. Okay, now to cater to this large canvas of clinical spectrum, you will have multi-level of equipment requirement. What do I mean by that? You will need a critical care equipment. Very critical, say anesthesia machine in OT, say a ventilator in, kind of ICU, or a defibrillator. You must have seen the movies, if they give shock to the patient to
Yes.
revive, to get help the patient revive. So all these equipment are critical care. Okay, then you can go to the surgical care. Surgical care is typically operation theater equipment, a OT table or OT light, all types of saws and drills, your syringe infusion pumps, a heart lung machine. All these come under the category of surgical care. Then you go to the radiology and imaging, cath labs, your CT, your MR, your ultrasound, your X-ray. All these fall under the category of radiology and imaging. So see the level: critical
Yeah.
care, surgical, radiology and imaging. Fourth is, say, a CSSD, which basically disinfects the instruments which can be reused in the operation theater. Then you have pathology for all types of blood investigation. You have blood bank. You have therapeutic equipment like a dialysis machine, like a dentist, kind of a dental chair. All these, it doesn't stop here. It further goes to medical infrastructure, ranging from modular OTs to a medical gas pipeline to a pneumatic chute system to a nurse call system. All these fall under the category of medical infrastructure. And not last but not the least is the medical furniture, your examination couches, your 7 function patient beds. All these, are kind of a huge equipment spectrum which caters to the large canvas of the clinical spectrum for kind of tertiary or a quaternary care. Now imagine, Ishan, I mean, all this equipment put together, typically for a 200 or 300 beds capacity hospital, you will find this equipment in the range of 700 to 800 numbers in a hospital. It's a huge number, and who will
Yes.
take care of this? So you require a biomedical consultant who can plan this equipment, who can help the client in selection of the technology, which level of technology is to be selected. Okay, how many equipment are to be bought for which department? Suppose you have ENT. So in what does it entail? What all you should have in ENT department? Suppose you have ophthal. What all comes in the OPD? What all comes in the surgery? The operatory room. So the consultant plans this equipment, plans the number of equipment per department. Okay, the consultant also helps the client to make the client understand from which vendor which equipment is to be bought, for what type of tender specification or technical specification, because each equipment will be kind of different from other in some or other way, and appropriately at what cost, that is also important. So
Correct.
biomedical engineering, compiles all this data on a piece of paper and helps the client to basically, to buy a equipment which is fit for the purpose.
Okay.
So that's, in short brevity, I could tell you about the role of, why a biomedical consultant is typically required in a hospital setup.
Okay. Wow. Lots to learn.
Yeah,
Yeah. So how do you keep a track of? I'm sure there must be new equipments also coming in the market every day.
yeah,
How do
yeah.
you like really keep a track of what's coming up, what's new, what is getting outdated?
Right. So in this particular regard, vendors helps us.
Okay.
They are our technology partners. I don't call them vendors because as they require us, we also require them. So they keep on meeting us. There's a new equipment is come. This is some new technology. This is some new AI feature. Come to our factory. Come to our office site where we have basically kept an exhibition of our equipment. Some road shows, some typical what we are setting in Goregaon. So our this Goregaon has kind of medical exhibition once a year. So sometimes you go to outside India, kind of there is Arab healthcare, or there is some kind of German, Medipa something. I don't recollect the name right now. But if you go there, it's a universe of the equipment or technology, and over there you get updated and upgraded.
Okay, nice. So I think the next question would be, how does a biomedical engineer help in this process of acquiring medical equipment?
Okay, if client decides to basically appoint a biomedical consultant, actually it can help the client immensely. First is cost implication.
Okay.
I'll tell you the kind of the crux now. See, 30% of the hospital budget goes into the medical equipment. Suppose you have a kind of kind of a plush hospital, kind of the ambience is good and well made, well constructed. The hospital, say it's at 100 bed capacity. Suppose you spend 100 crores into that, huge number, big cash. Out of those 100 crores, 30 to 33 crores, depending on your clinical spectrum, will get attributed. I'm not saying contributed, attributed by the medical equipment. So, see, I mean, 30% is not a small, it's a huge percentage. So, the biomedical consultant can control this cost. Not only control, but optimize this cost. Can help you buy the right technology equipment for the appropriate intended patient case. Okay, I mean, the fit for purpose, as I said. So, the one who can save crores and lakhs of rupees for the client, that is the main, kind of mainstay of a biomedical consultant for a client. That is one. Second thing, see, if the equipment works for a long street, 10 years, 12 years, so it works for hassle free with minimum downtime, there is low maintenance, low recurring costs. So at the end, it helps the organization to maintain a good cash flow, and you get a better ROI. Suppose there is no biomedical consultant, and the person is new, the investor or the stakeholder is new in the market, and he buys the equipment. Okay, suppose he buys the equipment from a substandard vendor with low quality equipment, with high recurring costs. And suppose his hospital is working well, his or her hospital is doing good, and at the fifth or seventh year he has actually started breaking even. And suppose at that time equipment starts failing, again you'll have to revise whatever you have gained into the equipment kind of infrastructure. So to avoid that, if you hire a biomedical consultant, it will help you save the cost.
Understood.
That's the main motto.
Okay, I see. It was nice to learn about all the technical aspects.
Yeah.
Now I want to know what the everyday overall process looks like.
Okay, so overall process is, you mean to say the planning and procurement.
Yes.
Okay,
Yes.
so to start with, every organization or every hospital has overarching goals. Okay, they have a multi-year strategic plan to invest, whether it is infrastructure, equipment, or whatever. It would be a civil. So client is the main, mainstay or the foundation of the bedrock in the entire process of procurement. Why client? Because as a biomedical consultant, you should know the client well. What do I mean by that? You should, the client goals and vision should be known to you. Okay, your activities should be aligned with the client vision and goal. What do I mean by that? You should know what is up with the client. Why is he putting up a hospital? In how many phases he is going to do that? What capacity hospital he will be putting? Why phases? So that you can decide the procurement timeline. See, ordering a MRI equipment, ordering a ventilator, the time to come the equipment to the site varies. Typically for MRI, it's in the range of 4 to 6 months. So you need to decide when a PO is to be released for MRI, and ventilator can come to the site into say a stipulated time of 2 months. Okay, so accordingly you have to kind of release the POs. So you should know the client well. What is his budget? The main, that's the main client is the main fulcrum, and the budget is the second. So what is his budget? What is client up to with respect to the brand preferences? Is he going to prefer imported, or is okay with the make in India concept, or he's going to have a mix and match of all that? So these things are to be known to a consultant. Okay, otherwise you cannot proceed. Then you should also understand what is the level of technology a client is kind of planning to have. What do I mean by that? Is client okay with 1.5 Tesla MRI, or he requires a 3 Tesla MRI? There is a lot of difference. I mean, though the 90% of the work can be done on 1.5 Tesla, but why this X, that the extra 10%, what is that 3 Tesla can do, what 1.5 cannot, should be made known to the client. Similar ways, what is a 32 slice CT or 120 slice CT? Okay, 120 is typically required for the cardiac evaluation. So is he going to, so you should know his need assessment. Is he going to cater to a particular specialty, a geriatric or a bariatric or a mother and child or only pediatrics? What is his plan? Accordingly, you will have to devise your equipment plan. So the level of technology, is he okay with say 10-inch cath lab flat panel detector, or 12-inch or 15-inch or 20-inch? There are different various FPDs available, flat panel detectors. So you should make client also know or understand these are the various formats available. What should suit you? A client and a consultant should always talk with each other. That communication is very important. Otherwise, it's a kind of fiasco. So the level of technology, as I said. Then budget, as I told, because budget, the main, it varies from imported to India make equipment. A ventilator, a imported ventilator can cost you around say 20 to 25 lakhs, whereas India make can cost you around 5 to 6 lakhs. So all these, kind of the permutation combination has to be played well with the client. So he's the main person. Okay, all other things come later into the picture. But once you are on the same page with client, the entire process gets simplified.
Understood.
Yeah.
I see.
So client is one. Which are the other multiple, kind of dependencies? As I'm explaining you the entire process, the second fill which comes into the picture is the architect. Most important. Okay, after a client is architect. Why architect? The room planning, the space planning. What will be your helium exhaust? It should not be come into contact of normal we people. Okay, it should be away from the typical hospital occupied area. So what will the helium kind of exhaust? What is the door clearance? Is it 1.5 meter? Is it 1.8 meter? So that the equipment can come inside easily. What are the regulatory compliances? Typically ARB. Okay. What is the thickness of the door? Okay. Where entire flow in the department, where exactly my equipment will lie, where it will get parked, what will be the turnaround space for the equipment, how the equipment will be oriented. Will it be closing, facing to this door, or it will be away from the door? All these inputs, all these kind of nitty gritties are to be planned with the architect post the client meeting. Client is always there in the involved throughout the process, but the second fiddle is architect.
Yes.
Similar ways, the third is structural. Equipment are huge, like elephants. MR is 7 ton, a cath lab and CT is 3 ton. So you have to talk with the structural consultant. The equipment weights are this. So this is the point load. This is the distributed load. This is the rigging path from where the equipment will basically come to the site. Okay. Any other SITC components? What do I mean by SITC? Supply, installation, testing, and commissioning. Any typical slab thickness you require. All these technical details will have to be kind of discussed with structural engineer.
Okay.
Okay. Third is your interior designer.
Yeah.
Okay. What will be the size and shape of the equipment? Okay. Typically in pathology, the equipment will be floor mounted or a bench top or under the table, over the table. Are you going to have double arm, double column pendant in OT, or are you going to have bedhead panels in ICU? Okay, all this, or what is the medical furniture? What is the kind of length and width of the patient bed? Is the maneuvering of the bed going to be easy? All these technical details to be discussed with the interior designer.
Correct.
Okay, and then the MEP, the mechanical electrical plumbing. Okay, equipment run on electrical supply. So whether it's going to be a 3-phase or a single phase. Okay, how much air conditioning is required to cool off the equipment? That is a BTU.
Yes.
Okay. Then typically say what else is required in MEP? What are the your other prerequisites to run the equipment? What is the water quality you require? Okay, is it will the pathology require RO water or distilled water? What is the tank capacity? All these nitty gritties or the technical kind of compliances to be discussed with MEP during the entire process of procurement. And then the last stage comes wherein you release the PO to the vendor.
Okay.
This is the in short kind of the procurement process
Mhm.
what happens.
Okay. So maybe a small question. So are there at any point any reviews with doctors that happens during this entire
Yes,
process?
the client mostly is a doctor
Okay.
or a kind of the investor,
Okay.
stakeholder, whatever you call
Yes.
it.
Yes. Yes. Yes.
Mostly a doctor, so doctor understands everything.
Okay.
Only thing they remain busy in their surgeries or kind of with
That's true.
patient. They struggle to keep the track with the rapid advancements in the medical technology. So
Correct.
this is the only you need to impart on knowledge transfer so that client comes on same page with the consultant.
Okay. Understood. Okay, so now that we have learned about the theoretical as well as the practical work profile of the biomedical engineer, I want to ask what would happen in a scenario where if a client does not engage in the services of a biomedical engineer?
Okay, if yeah, see, to err is human. Okay,
Yes,
similar means I mean none is perfect. You are bound to make mistakes. While making a hospital, nothing. You understand, nothing is perfect. But suppose if you hire a biomedical consultant right from the conceptual to the operational stage, these errors can get reduced. What do I mean, man? How do I tell you this? For example, point number one, a client may end up buying a non-future proof equipment. Okay, suppose he is putting a modular OT, but there is no OR integration in the modular OT. So tomorrow, if he wants to showcase his case, he wants to live streaming or kind of recording, or wants to make the anecdotes while the surgery is on. He wants to show kind of a bi-directional talk with the people sitting in the auditorium and the surgeon in the operation theater. This, if he misses to have this, is a loss. Okay, I mean you should have this. So the client may end up buying a non-future proof equipment. Second, the client may end up buying an equipment which is substandard from a substandard vendor with low quality, low tenders, low technical specification. Okay, with high recurring cost. These are the pointers where you may miss or you can get a shot.
yes.
Okay, what else? Suppose the vehicle parking area is planned close to the ISO center of the MRI,
Mm.
or the EEG and EMG equipment are close to the lift. What will have the kind of after effect is it will create the artifacts in the equipment, so the result won't be precise and accurate. Okay, these are the kind of jeopardies or the losing concerns. What else? Suppose the door clearance is not good. It's just 1 meter. Normally, for a bigger equipment, you require easy maneuvering. You require 1.5, 1.8, typically in the OTs and all. So then, what all it will entail if all these are kind of a miss shot? You'll have to break the walls. You'll have to break the door. You'll have to core cut. You'll break the slab. Whatever. I mean, then it's lost.
Yeah,
So all these errors could be reduced if you have a biomedical consultant right from the conceptual to operation stage.
correct. I see. Wow, the job of a biomedical engineer entails a lot. Like you,
Yeah.
I'm kind of impressed. You know a lot about architectural, structural, and MEP features as well. So, what I wanted to ask is, are there any particular limitations that an in-house biomedical consultant would have?
You mean the resident biomedical?
Yes.
See, I mean, engineer, I mean, he's a talented guy. He knows his subject. He works day in, day out. The thing is, the resident biomedical engineer normally gets occupied
Mm.
in day-to-day firefighting.
Correct.
He hardly gets time for the equipment homework or to do some research work, to attend some road shows or the medical exhibitions. He's most of the time gets occupied into handling the equipment, liaising with the vendor, attending calls, all sorts of breakdown maintenances. Again, I mean, you never know which equipment will fail when. So he has to be on his toes, on his tenterhooks all the time. So he doesn't get enough time to work on the equipment per se separately or dedicatedly.
Correct.
Whereas a biomedical consultant, is a dedicated source to that particular equipment need of the kind of the client. So you can call the biomedical consultant, if hired separately, as a third eye or a bird's eye view of the entire equipment procurement process.
Correct. Understood.
Yeah.
Mhm. I think the next question would be, are there any other services that entail in this biomedical domain?
Yeah, I mean, the first is, as we have been talking for long, is the planning and procurement of the medical equipment. Second is, one can do a biomedical departmental audit in lineage with the ISO or NABH. Okay, is the documentation process, well in place? Are the equipment running well? Okay, is the department process driven or kind of protocols based? All these things can be, kind of highlighted if you do a biomedical audit. Mostly is about the documentation and the I mean you if you have a record for whatever activity you're doing. Suppose you get a code blue call from the casualty. Okay, so your reporting time is 5 minutes. Suppose, I mean, God forbid, the engineer is not able to solve that problem, but at least he has reached to the site, rushed to the site in time. That is also important. Okay, he may give a better alternative and solve the problem in and there itself, but all these processes, are those being maintained? Are the equipment being maintained as per the manufacturer guidelines? What's your preventive maintenance schedule? Or how do you calibrate your equipment? How do you validate the equipment? All these technical glitches or the technical parameters can be monitored when you do a biomedical department audit. So this is second. Third is, normally when what a client comes to a biomedical consultant is when a client sells or buy a hospital. So they need to know what is the depreciated value of the entire medical infrastructure, furniture, equipment, devices, instrument, all put together. What is the today's cost, salvage value, depreciated? And suppose they want to buy everything new, what is the replacement cost? So that is where the client approaches a biomedical consultant. Very important. And fourth is, the since I work in HOSMAC, I work with other departments also, so I know the high side engineering items. So when I go to a hospital, I not only see from the biomedical perspective, but also from the MEP perspective,
Correct.
the UPS, your DG, all that put together.
Mhm. Understood. Yes. I think the next question would be, are there any other services that entail in this biomedical domain?
Yeah, I mean, the first is, as we have been talking for long, is the planning and procurement of the medical equipment. Second is, one can do a biomedical departmental audit in lineage with the ISO or NABH. Okay, is the documentation process, well in place? Are the equipment running well? Okay, is the department process driven or kind of protocols based? All these things can be, kind of highlighted if you do a biomedical audit. Mostly is about the documentation and the I mean you if you have a record for whatever activity you're doing. Suppose you get a code blue call from the casualty. Okay, so your reporting time is 5 minutes. Suppose, I mean, God forbid, the engineer is not able to solve that problem, but at least he has reached to the site, rushed to the site in time. That is also important. Okay, he may give a better alternative and solve the problem in and there itself, but all these processes, are those being maintained? Are the equipment being maintained as per the manufacturer guidelines? What's your preventive maintenance schedule? Or how do you calibrate your equipment? How do you validate the equipment? All these technical glitches or the technical parameters can be monitored when you do a biomedical department audit. So this is second. Third is, normally when what a client comes to a biomedical consultant is when a client sells or buy a hospital. So they need to know what is the depreciated value of the entire medical infrastructure, furniture, equipment, devices, instrument, all put together. What is the today's cost, salvage value, depreciated? And suppose they want to buy everything new, what is the replacement cost? So that is where the client approaches a biomedical consultant. Very important. And fourth is, the since I work in HOSMAC, I work with other departments also, so I know the high side engineering items. So when I go to a hospital, I not only see from the biomedical perspective, but also from the MEP perspective,
Correct.
UPS, your DG, all that put together.
So, speaking of Hosmac, actually, how do you think Hosmac shades better than our other competitors?
Okay. You also know better, Ishan. I mean, Hosmac is a 28 years young, I should say.
Yes.
It's a planning, designing, and hospital consultancy firm. So whatever we spoke for last, some time, all these verticals, no, I mean, the architecture, the structure, your ID, your MEP, your project management consultancy, your HCS, all these verticals are under one roof.
Hmm.
So it's a one-stop solution. Okay. As a biomedical consultant, I need not depend on the external factors. I need not depend on the external architect or the external MEP consultant or a ID consultant. Everything is, in-house. Okay. So the work coordination becomes better. Okay. It helps in improvement of the overall project outcome and efficacy. So I mean, it's a one-stop solution, as I said, and our process is SOP based.
Hmm.
So at what level a biomedical consultant should talk to architect within HOSMAC or a MEP consultant within HOSMAC or a ID is all kind of pre-planned. So the work coordination becomes simpler, and it gives a different shape altogether to the overall project outcome.
I see.
So that is the advantage of working in HOSMAC.
Yes. Wow. It was a very nice half an hour, more than half an hour long, I think, understanding of how and what a biomedical engineer is in the first place. I'm sure we will do more of these podcasts about various different topics to learn
Yes.
more about healthcare.
Right. In fact, I'm also happy. I mean, kind of this kind of opportunity should be, kind of given to the biomedical people, because these people are not known. There's a
Yeah.
background, the artist, in a typical movie, the
Mhm.
one who is a background technician. Similar way is the kind of scene for the biomedical. So
Yeah.
I hope the listeners would have understood the essence of this, of our conversation, and eventually appoint a biomedical consultant for the upcoming project. Thank you.
Thank you so much for watching.
Thank you.